Hello friends, very good morning and very warm welcome to this course on welding metallurgy. So, it is my pleasure to be associated with you all. We will be studying this course welding metallurgy. Hopefully, you might have seen the syllabus of the course and I will be glad to be with you. So, this is the first lecture of the course and we will have the overview of the course as well as the introduction of the topics like welding metallurgy, how it will be useful for us. As you know, let me give you some brief information that this is a 12-week course. So, we will have different topics that we will discuss later, and in that in every week we will have one assignment. So, that assignment will be visible to you. You have to solve the assignment questions, you have to submit it. So, ultimately it will carry certain weightage and then you will have the final examination towards the end. So, many of you I hope have taken this course as a credit course, and depending upon how you perform in this course, you will be able to use these marks or the grades for the academic purpose or for other purposes. So, I hope that you will be getting a full benefit, and I will be also giving my best to make you understand, to to make you fully be aware about the contents of the welding metallurgy course. So, as we discussed that this is a 12-week course and we will have different topics which will be covered. Now, the topics which we see that as we go week wise. So, in the first week we will talk about the introduction to welding metallurgy, and then we will talk about the phase diagrams. We will slowly come and discuss about the importance of the various topics, how they are going to be used in context with this course. Then you have phase transformation. So, phase transformation, you might have also the introductory knowledge about the phase transformation. So, we will talk about the phase transformation processes, metal strengthening approaches, that is another topic where we will talk about the different approaches, how to strengthen the metals and alloys. So, we will talk about it. Then you have heat treatment processes. We know that we try to enhance the mechanical properties of the material by different types of heat treatment processes. So, that will be covered under that in that week. Then heat flow and temperature distribution in welding. So, in that basically we will talk about how the heat flow is there during the welding process, how the temperature distribution is at different places, and then how the temperature varies with time. So, that will give you an idea of temperature gradient. Then depending upon that there will be microstructural changes. So, that will be discussed. Then you have concept of solidification in welding. In the week 6 we will talk about the different types of welding solidification processes, especially in casting and welding. So, normally when we talk about solidification, we normally cover or relate that with the casting processes, but the similar type of concept is there in the case of welding also. So, that we will have certainly today we will be having some light over that. Weld crack metal cracking will be in week 7, heat affected zones week 8. Week 9 we will talk about the crystallization and grain growth phenomena. Then week 10 will be partially melted zone, grain boundary solidification. Then week 11 is liquefaction cracking, hydrogen cracking, and in the end, in the 12th week we will talk about the metallurgical issues in welding. So, overall you will have these 12 weeks, and in all these 12 weeks we have 5 lectures each of approximately 30 minutes of duration. So, altogether we will have a very good time in between where we will discuss in detail about the different topics. We will have it later. We will talk about it little bit in detail. Now, talking about the welding metallurgy course, as you know. So, welding metallurgy has two terms. One is welding, another is metallurgy, and I hope that you are aware of these two terminologies. So, as we know that welding which is also one of the joining processes. So, it is a process in which materials of the same fundamental type or class are brought together and caused to join through the formation of primary or secondary chemical bonds under the combined action of heat and pressure. So, if you try to look at the different type of welding processes or joining processes, as you know. So, we know that you have different type of joining process, that is, one is mechanical joint where we use these rivets, we use the nuts and bolts. So, they are basically so there may be permanent or So, once we talk about the if you talk about the joining processes. So, joining processes typically when we talk in a very broad manner, you may have the temporary type of joint, you may have semi permanent type of joint, and you have permanent type of joint. So, as we know that when we are trying to join for engineering applications, many a times you have to join two materials. Now, their joining can be either temporary or semi permanent or permanent. Now, in temporary means you have metal which is two parent metal which are to be joined. So, in the case of temporary, you can, whenever you feel, you can dismantle them, you can take them apart, and both your the parent metal as well as the metal with which you are joining, the medium with which you are joining, they are intact, like you have nut and bolt joint. So, that is the example of temporary joint. Similarly, you have a semi permanent joint where whenever you try to dismantle them, you have to take them, separate them. In that case, your parent metal is not at loss, you are not losing, but certainly the medium with which you are joining, that is lost. So, that is your semi permanent type of bond, and you joining, and that is the typical example is rivets, because when you remove these plates which are riveted, then the rivet material is gone. And then comes the permanent joint. So, in that permanent joint, basically we are concerned with those processes where it is a permanent type of joint. If you try to remove them or separate them, or in that case there is loss loss to both. So, because the joining is at molecular level. So, you have nothing, both of them are to be altered again for further application. So, in this case, when we talk about welding metallurgy, so this is basically the welding classification of welding process in that, and then in this case we are going to talk about the processes which are coming under these permanent type of joining processes. And again, in permanent type of joining processes, you may have classification based upon the type of heat source. So, whether you apply pressure or you are not applying pressure, your type of source may be based on electric, based on chemical, that is fuel. So, you will have basically fusion type of welding in these cases, and when you fuse the material and when you do the joining, in that case, because of the high temperature, there is likelihood of and there is certainty also on the changes in the microstructure of the material in a zone. So, that zone basically has the changed structure, changed mechanical properties. Now, that is to be understood how that is changed. Then while joining also, what kind of changes take place, what needs to be taken into account, so that ultimately you are getting a good weld. So, basically when we talk about temporary joint or semi permanent joint, we are not we are thinking of in temporary you are simply thinking of joining. So, we are not going into that metallurgical aspect. Whereas, when we are going to permanent type of joint, especially the fusion welding processes, now in those cases you are melting a zone, and then that zone gets solidified. So, during that process, whatever changes occur typically in a casting process, like you will have the solidification. Now, most of the defects which are coming apart from the defect which arise due to molding material, they are separate, but the defects which are coming because of the weld metal, cast metal. So, those kind of defects are likely in this case, because this is also a type of solidification. So, in these cases you need to look into those aspects to ensure that your weld metal, ultimately your aim is to have a sound weld, so that you have better mechanical properties towards the end. So, what we see that in this case you are your purpose is to join them for formation of the bond under the combined action of heat and pressure. So, both the actions are there, and under that you are basically your aim is to have the best mechanical properties, defect free product. So, you are thinking of having such you have to analyze on many aspects what way the properties may change, what way the properties may be affected, how the how the physics is can be interpreted basically while doing that process. So, all these things we will have certain session or lectures. So, we will have these lectures in a continuous manner, and we will talk one by one about all these processes. So, in that we will see that we have to discuss about the metallurgical aspects, material science aspects. So, in that we are going to talk about the phase diagrams, where we will see that how the two metals which are going to be welded. Now, if or filler metal which is there in the weld pool, so how they are going to make the compounds, whether we are not going whether we are likely to have any undesirable intermetallic compound formation, or how good gelling will be there. So, those aspects will be studied. Then we are going to also talk about the strengthening approaches and all that. So, metallurgically you must be able to better understand, so that you are able to give a good weld joint. So, as we discussed that welding, we know that welding that is a process. Then metallurgy, what is metallurgy? That also we know that it is the science and technology of metals. So, in that we are talking about the science and technology of the metals, how we are talking that concept is coming from the physics, chemistry and crystallography. So, basically we talk about the material science aspects. In that we talk about the metals, different type of metals, their behaviors, then how they can how they can interact with them with each other when they are molten. So, that will be based upon the phase diagram principles that we will see that what type of phases are formed at what temperature, and in that also we can discuss further about the phase transformation processes. We will talk about the solidification mechanisms, we will talk about the different phases which are formed by undergoing the different kind of atmosphere, like if you have different type of cooling mechanism, if you have different type of heat treatment, then how the different phases are formed and how their mechanical properties will be different. So, all these things we have to understand in that, and then different way of different types of processes will also be studied. to understand it better. Now, coming to know more about the metallurgy, so it is the science that explores why metals behave the way they do. So, in metallurgy normally that is what we are trying to understand, that why metals behave in a certain manner, why certain metal will be giving you more strength when you edge, or why certain metals will give you more strength when you cold deform them. So basically in the case of science of metallurgy, we are going to talk about the behavior of the material, and it will also explain the properties, behavior and internal structure of metals. So, in that we try to understand that what is the internal structure. We go from crystallography, we talk about how the crystal structure is, how it is going to have the different properties when combined with other material. I think these things you must have studied in the course of material science. Then from there we will be able to explain the properties, behavior and structure of metals. It will also describe the treatments and processes that allow us to tailor a metal's properties to a specific application. Now, when you know that what will be the behavior of the material when subjected to a certain kind of treatment, then depending upon the need, upon your need, you can try to tailor the material's properties. You can have the different type of treatment you can give to materials, and in that you will get the tailor made properties that can be used for a particular application, and that way it will help you to come up with new and new materials which are used for, which have to be used for different type of advanced applications. So, nowadays we certainly need we have the need of welding, and for that at many places, and for that we must understand that when you have the tailor made materials with tailor made properties, then how to again further weld them, because you see, once you have the material, the challenge is that how you can increase the longevity of the component, because many a times they fail. So, rather than bringing the new material, you can use them by welding, and then further use it for a large amount of time. So, that will increase the productivity of the organization. So that will be the metallurgy. Then welding, when we talk, that is basically kind of procedure or technique which is entirely appropriate for one and disastrous for another. So, that is what we needed to discuss, that if suppose you have one metal and you have come to a different type of a process you have fabricated for, you have devised. So, you cannot say that that will be used for another metal too. So, many a times if you use the same thing, then that may be disastrous for other. So, you must have the proper understanding, you must be very familiar with different types of base materials and how they are affected by heating and cooling processes. So, basically when we talk about welding, so it is nothing but when you talk about fusion welding, so you are heating and then you are cooling. Now, the way you do for one metal and the way you do for second metal, that may have a different effect, completely different effect. So, these things need to be kept in mind, so that you get the best properties. Now, certain issues, like although most of the welders gain knowledge of metals and a metal's weldability over many years, often it is incomplete because it is limited to the processor materials used in particular shop or industry. So, as we discussed, that many a times some person may be working on a certain process or on a certain material for many for large amount of time, but that does not mean that he is expert in all these all other processes, because the mechanism is different. the result which have to be obtained, they are different. So, you need to have a more complete understanding of metallurgical principles. So, that is required. You must know the metallurgical principles, you must know the metallurgy behind it. So that the relationship between metals properties and its composition. So, if the metal is having different composition, what will be the properties? Like many a times you are welding two metals of same composition with and you do not have a filler material. So, you are using filler material of different composition. You must be able to know that if you are using the filler material of different composition, then what way it is going to affect the mechanical properties in certain area, especially in that weld pool zone. So, that composition and then the function of the processes such as cold working, alloying, heat treatment, all these things will have what kind of effect on the material properties, that needs to be understood. So, for that you need to study the welding metallurgy in detail. Now, this will allow us to have more awareness about the processes and materials and take appropriate decisions further. So, once you have a better understanding about the metals properties and depending upon its composition. So, basically many things will be clear from the concept of phase diagram. So, from there you will have a proper understanding that which of the materials have better gelling, they can make you a compound of better properties. So, from there and then also the phase transformation processes or the different processes like CCT or TTT curves will let you know that what kind of heat treatment process will give you which kind of phase which will be more useful. So, these things can be better understood when you study these welding metallurgy course. So, finally, what is the aim of the course? So, as we know that we have to focus on understanding the metallurgy and the solidification of weldments. So, first of all we must understand the metallurgy as well as the solidification of the weldments. Then make the students aware with the metallurgical aspects of welding. There are many issues, many metallurgical aspects are there in welding. You must be able to judge the weldability aspect also, how when you are welding two materials, whether how weldable they are, how good bond can be developed between them. So, that is these aspects need to be understood. Then you have to make the students aware of the science behind the welding phenomena, especially in the domain of weld metal solidification, heat transfer, heat treatment processes, strengthening mechanisms, etc. We will have one eye over there, and it can be used for engineering graduates as well as professionals working in the area of welding. And as we discussed earlier, so now we can see that these are the topics which are going to be covered. So, in the first case we will have introduction to welding metallurgy, and we will talk about the phase diagrams, where you will try to have the overview of the metals and its composition, its effect on the properties. So, and different type of phase diagrams for ferrous as well as non-ferrous materials. So, what is the concept behind the use of phase diagrams and how that can be useful when we are studying the welding subjects. Then you have phase transformation. In that phase transformation we are going to talk especially about the solidification aspects, how the different type of heat treatments are So, in the phase transformation basically we are going to talk about the CCT or TTT curves. So, how the different phases which are transformed, how they are different when you have the different type of treatments given, different type of heating or cooling given, how they will give you different phases. So, that will be under phase transformation. Then you have metal strengthening approaches. In that we are going to talk about the different mechanisms, because we know that we do not use normally the pure metals for the engineering purposes, because they are either too soft or too ductile, too much ductile many a times, and we have to compromise on strength in many cases. So, you have to strengthen them, and strengthening can be based on many principles. You may have the strengthening by giving proper treatment, or you may go for the precipitation hardening. So, there are different types of strengthening approach that needs to be discussed, and basically that also will be useful while doing the welding. Heat treatment processes, we know that these processes are used to enhance the bulk properties of the material, many a times the surface properties of the material. So, different type of heat treatment processes are there which are to be used. In the case of heat flow and temperature distribution in welding, now in this case as you know that in the case of welding, if you take the example of welding, it is nothing but, when you talk about the fusion welding, it is nothing but the movement of a heat source in a particular direction, and you have the heat dissipation on the sides. Now, as this sides on the both sides you have parent metal, and that is normally of very small dimension. So, the heat transfer rate is quite high normally, and how the heat transfer is going to be, how much fast it is, and how it is going to affect the properties, how the speed of the welding is going to affect the properties. So, these different things will be discussed in the case of heat flow and temperature distribution in welding, how the temperature will, in which area temperature will be more, how it will decrease in the nearby zones. So, that will be studied in that. Then you have a concept of solidification in welding. So, in that basically solidification in welding is somewhat different simply because in this case in the case of solidification, we know that normally you have heterogeneous and homogeneous type of nucleation, and that is basically further after nucleation you have growth. So, that is normally the mechanism of solidification. Now, it is a kind of heterogeneous nucleation where you have one layer which is available, and from there will be further growth. So, in the case of welding, it is normally epitaxial type of growth, and depending upon the rate of solidification or the degree of temperature gradient, the temperature gradient which you are getting in that case, that will be deciding how much brittle will the metal be or how much ductile the metal be, whether you need to give further any treatment to reduce the brittleness which you have achieved by the sudden cooling of the material. So, all that weld metal cracking. So, that is cracking is another issue, because when you do the welding, so because of the heat flow, because of the large temperature gradient, because of the stresses involved, you have the examples of cracking. Cracking is very common in the case of weld metal. So, that needs to be understood, what type of cracks are there, what are the reasons for these cracks and how they can be avoided. So, all these things are studied. Heat affected zone, as we told that heat affected zone is required to be understood, because when you do the welding in certain zone, the temperature, the microstructure is affected. Now, there the properties will be affected. So, how to reduce that zone, what are the methods by which you can have the reduction of those zones, and how they are going to affect the properties. So, basically based on that you can decide what way these materials can be used. So, that will be in the heat affected zones. You have crystallization and grain growth because of the high temperature which you are going, because you are going to the melting zone in this case. So, you will have crystallization and grain growth, and how that is going to affect the properties. We will study different aspects of that. Then you have partially melted zone, grain boundary solidification, that is another issue which partially melted zones are there, because at the fusion boundary zone you will have the partial melted zone, and then you have the grain boundary solidification also. So, these aspects will be studied. Cracking, hydrogen cracking, that is cold cracking. So, that is another way, another challenge in these cases, and then further we will talk about the metallurgical issues. So, what are the different challenges which we face in the case of the welding, and I mean from metallurgical point of view. So, this will be normally the course overview. We will be having the lectures in continuation, and we will be having more and more interview. We will have also some live interaction about the different if you have any kind of clarification required. So, we will have also the interaction in between, and hope that you will enjoy the lectures and you will enjoy this course and do good by scoring more and more in this course. Thank you very much.